Hi everyone, in this video we are going to talk about how we can develop a multiple linear regression model. In another video we talked about how to build a simple linear regression model. So if you haven't watched that video, I strongly recommend you to watch it before this one, and I will put the link to that video in the description for this video. So to illustrate to you how to build a multiple linear regression model, I prepared an example here, and we are going to go over this example to understand how we can create a multiple linear regression model and how we can read the output. So we have a sample data for 15 employees that work for a company. This data set includes the number of years of relevant work experience, the age of the employee, and whether or not the employee has a graduate degree, along with the salary, the annual salary for each employee. And we have a number of questions here, and we are going to answer these questions one by one. Okay? So let's go and look at the data set. So this is our data set. We have the annual salary and the number of years of experience, the age, and if the highest degree earned by this employee is an undergraduate degree, we have undergrad here, and if the person has a graduate degree, we have the graduate note here. So in this case, we are going to understand how these three factors affect the annual salary of an employee. And the way we understand this is usually given by the question or from the context of the data set. So if we look at part A, the question is asking us to create a regression model that could be used to predict the salary based on the number of years of relevant experience, the age, and whether or not the employee has a graduate degree. So this tells me that we are trying to predict the annual salary given these three factors. Okay, so my response variable is the annual salary, and the predictors are the number of years of experience, the age of the employee, and the highest earned degree. All right, so these are the predictors and the response variable. Another way to identify the predictor and the response variables in this example would be that, for example, would the number of years of experience affect the annual salary, or would the annual salary affect the number of years of experience? So in other words, does the annual salary depend on the experience, or does the experience depend on the salary? So you can ask questions like that. For example, does the age depend on the salary, or does the salary potentially depend on the age? Or having a graduate degree affects the salary, or the salary affects the graduate degree. So it's kind of asking these questions to identify what could be affecting the other factor, other variable. Okay, so in this case, the experience, the age, and the graduate degree would affect the annual salary. Therefore, these three are the predictors, and the annual salary would then be the response variable. So here's a tricky part with this data set. You can see that these three components are all numbers. But if you look at the column under degree, you can see that these are not numbers. Okay, so we have categories here. The categories are undergraduate or graduate. So for these kind of situations, we use something called a dummy variable. Okay, so a dummy variable will help us convert this categorical data into a numeric or quantitative data. Okay, so what we are going to do is, let me just take a note here. So we are going to define this number of years of experience as x1. Okay, so it's the first predictor, and we have age as x2, which is our second predictor, and then we have x3, which is the third predictor. And I'm going to define this as x3 equals 1 if the employee has a graduate degree and 0 otherwise. Okay, let me just move it somewhere in here. So x3 is equal to 1 if the employee has a graduate degree and 0 otherwise. Okay, so what I'm going to do is I'm going to add a column here. So I'm going to right click on my mouse and then say insert, which adds a new column right next to age. And what I'm going to do is I'm going to type graduate here, and I'm going to convert this categorical data into numbers by using this data under degree. So the idea behind this is whenever I see an undergraduate here, I want to see 0. And whenever I see a graduate here, I want to see 1 on the corresponding cell. So I'm going to use the if function. You can do this manually by simply just say, well, the first one is undergrad, so I'm going to type 0. The second one is undergrad, I'm going to type 0, and so on. You can do it that way, but I'm going to use the if function. And in that case, I'm going to select E2, and if E2 is equal to graduate, so what this says is when I look at this cell, if I see graduate, then the value is equal to 1, and it is going to be equal to 0 if it is not graduate. Okay, and this is based on this definition that I listed. X3 is equal to 1 if the employee has a graduate degree and 0 otherwise. So if E2 is equal to graduate, then the value in D2 will be equal to 1 and 0 otherwise. So hit return or enter based on your computer. This is going to be 0. And since I'm going to repeat this for all of these remaining rows, what I'm going to do is to go to the bottom right and drag this function all the way down to create all the 0s and 1s. So what happened is, as you can see, whenever we see undergrad, graduate, we have 0s, and when we have graduate, we have 1s, and so on. Okay, so this is created automatically. To make space, I'm going to delete this because we already know what that definition represents. The next step is to create a regression model. Okay, so the first question is asking us to create this regression model. So I'm going to go to data analysis. So we are going to select regression, and the first question that we are going to answer in this new menu is the input Y range. Input Y range is asking us to provide the response variable. All right, so the response variable is salary, and we input the salary data into input Y range. The input X range is asking us to list the data of predictors. All right, we have 3 predictors, and we already listed them here. What I'm going to do is pretty straightforward. All you need is to select all of these at the same time. Okay, so all of these, select them and make sure that you have B2 up to D16. Okay, so this select region shows up in input X range. I don't need to say anything about labels or constant 0. Confidence level by default is 95%. So the confidence level is 0.95. I'm not going to change it. I'm going to leave it as 0.95, which means that my alpha value, the significance level, in other words, is going to be 0.05 because the significance level, or alpha, is equal to 1 minus confidence level, and that value is 0.95. The next thing that I need is to specify where I want to see my output, and I'm going to select an empty cell, which is G1, and I don't need to go through these because, again, please watch my simple linear regression model if you haven't already to see some details about this. So what I'm going to do is I'm going to say OK after selecting G1, and here we are. So we have our output, and we are going to read this regression output. Okay, so question A is asking us to create this regression model, and the regression model is given to us in this coefficients column. Okay, so the answer to part A is going to be the intercept, which is 116.850.8469 plus 19511.03. So I'm going to round up these values to move a little faster. minus 4964.63 x2 plus 3350471 x3. So I transferred these coefficients of x's from this column over here. Okay, so this is my regression model. Let's put y equals in the front. So y equals our intercept plus the coefficient of x1 minus the coefficient of x2 times x2 plus the coefficient of x3 times x3. Okay, so what we see here is, just looking at these, the salary of the employee will increase as the number of years of experience increases because of this positive value, and it will decrease as the person gets older, and it will increase as this dummy variable becomes 1. Okay, if it is 0, it's not going to affect anything. If it is 1, it's going to add some value. All right, so this is the answer to part A. As a side note, be careful with the dummy variables, because when you define a dummy variable, all you need is to look at how many different categories you have in your data, and you're only going to need one less than how many categories you have. So for example, since we have 2 categories here, undergrad and grad, I defined only one dummy variable, which was x3 equals 1 if the employee has a graduate degree, and 0 otherwise. And if I had, for example, 3 categories, then I would define 2 dummy variables. And if I had 4 categories, I would define 3 dummy variables, and so on. Okay, as a side note, I'd like to mention that here. The answer to part B, it is asking us to predict the value of salary of a 35-year-old employee who has 9 years of work experience with a graduate degree. All right. So what I'm going to do is I'm going to transfer these values, the intercept plus the coefficient of x1, which is the experience level. That experience level is 9, given by the question, because the person has 9 years of work experience, plus the coefficient of x2 times the age of the employee, which is 35. Okay, so be careful. I still put plus here because the coefficient, this coefficient is a negative value, and by putting plus here, it is transferring this value as minus. If you put minus here, this will become a plus because you're putting minus, which will become a plus. Okay, so make sure that you put plus here if you're transferring that value directly from the table. Okay, and the last component is this person has a graduate degree, which means that we are going to define x3 as equal to 1. So we are going to multiply this coefficient by 1 because the person has a graduate degree, and this is the salary. Okay, 152,000 roughly is this predicted salary. Let's look at part C. So part C is similar. The only difference is that the person doesn't have a graduate degree. Okay, 35-year-old, 9 years of work experience, and no graduate degree. Let's see what we are going to change. Again, the intercept is transferred. The coefficient of x1 times, what is x1? The number of years of experience. The question says it's 9, plus the coefficient is given in the table times how old is the person? 35 years old, plus the coefficient for our degree category, but in this case the person doesn't have a degree, doesn't have a graduate degree, which means that this value will be equal to 0. Okay, again, if the person has an undergraduate degree, the highest degree is undergrad, then this value is 0. If the highest degree is graduate, then this value is 1. But the person doesn't have a graduate degree, therefore the value for x3 will be equal to 0. And the salary is 118,000. So what we can see is if the person has a graduate degree, the difference is about, let's see what that difference is. This difference is about $33,500. Okay, so this is what we can tell, which is actually the coefficient of the degree category. Okay. it was that. So question D, let's see what the question is asking. How much of the variability in employee salary can be explained by your regression model? So how much of the variability is explained by your regression model is essentially asking you what the R-square value is. Okay, so R-square value is given in my output, which is equal to 0.927, and my answer is going to be about 93% of the variability in employee salary can be explained by my regression model. Okay. Again, high R-square values are desirable. It's usually good to have. In most cases, you're going to see that high R-square values are good. So 93% is very close to 100%. So that is a good sign. Question E. Is your regression model statistically significant? So to answer this question, I'm going to need my alpha value and I'm going to need the p-value. Alpha value, as I said when I constructed this model, is equal to 1 minus my confidence level, which is 0.95 by default. I didn't change it, so it's still 0.95. So that value is equal to 0.05. And the p-value of this regression model is coming from this ANOVA table. So this significance F value here is the alpha value. I'm sorry, the p-value. Okay, so the p-value here is a very small value. Make sure that you carefully look at this value because you're going to see this last part that starts with a capital E. That tells you that this value is a very small value. Okay, it's smaller than 0.05. You can also verify this by going to the corresponding cell and right click, format cells, and go to number. And you're going to see that right now it's showing only 2 decimal places, and what we see is 0.00. And if as I increase the decimal places, you are going to see the true value of what we are seeing in the significance F cell. Okay, so as you can see here, this is a very small value, and this screen shows the true value of this cell. So I'm going to transfer it over here. Since this p-value is smaller than my alpha value, I can conclude that the model is statistically significant. Okay? So this is how we answer this question. So first of all, you need to decide what your alpha is, which you determine before you create this regression model. And then you look at your p-value from the ANOVA table. And if that p-value is smaller than your alpha, which is the case for us, we conclude that the model is statistically significant. Okay? F, which predictors are statistically significant? Okay, so this is a good question. How we are going to answer this question is very similar to part E. But all you need now is to look at this last table that lists all your predictors, so x1, x2, x3, and you're going to look at their corresponding p-values. Okay? So the first predictor is experience. Okay? The second one was age, and then we have the degree. Okay? So let's organize these. So what I'm going to do is I'm going to look at the p-values from my table, and I'm going to compare those p-values to alpha, which is 0.05. Okay, alpha is still 0.05, so alpha is 0.05, and the p-value will be from the table. So 0.05, 0.05, 0.05. And the p-values will come from this table. Okay, so you have the title here. Let me highlight that. Or let me highlight all of these values. You are going to see that the p-values are given in this table. And for my predictors, I'm going to copy and paste these p-values. And then we are going to see if the p-value is smaller than alpha. Again, for the first predictor, the experience predictor, you can see that the p-value is a very small number. Again, look at the part that starts with the capital E. It's a very small value. Therefore, this variable is statistically significant, or in other words, this predictor is helpful to predict the salary. Let's put it there actually. Helpful to predict salary. Okay? The second predictor is age. Again, this p-value is smaller than alpha. We are going to say that it is also helpful to predict salary. And the last one, the degree, is 0.01, which is again smaller than alpha. And we are going to repeat the same answer and say that degree is also helpful to predict salary. So there could be scenarios where one of these p-values is greater than alpha, which is common. It can happen. And if that happens, what you're going to say is it is not helpful to predict salary. Let's say that the age has a p-value equals 0.2. Okay, 0.2 is greater than 0.05. In that case, you would say, well, age is not helpful to predict the annual salary of an employee. Okay, so this is how we would approach the problem. So it was the last question for this example, and thank you so much for watching this video, and I will see you in the next one.